Good day, students. On the board we have mathematics and we have conjugate rationalization. We want to rationalize sorts whose denominator or a sort having denominator more than one sort. How do we do that? Or maybe a sort having denominator of a sort and a number or a rational number. Okay, how do we do that? We have 4 over 2 plus root 3, and then we have 7 over root 5 minus root 2, and then we have 1 over root 3 plus root 5. There is something called conjugate of a sort. If you have, and conjugate is simply that number or that sort that you are going to multiply with another sort. Or, yes, the conjugate of if you multiply the conjugate of a sort with the sort, you are going to get a rational number. This is what I mean. If you have a plus root b, the conjugate of a plus root b is a minus root b. And if you multiply this, the answer is simply going to give you a squared minus b. We've done that before. If you multiply a plus root b times a minus, this is actually the difference of 2 squares. You are going to get a squared minus b. And this is a rational number. Okay, so using that idea, let us use it and solve this. Remember that for you to rationalize a sort, the denominator must be a rational number. This is not a rational number, this is not a rational number, and this is not a rational number. So, and we can't just multiply the numerator and denominator by any number or any sort. We must look for that sort that will make this a rational number, and that is the conjugate. That is why we have this name, conjugate rationalization. So, moving on, we have 2 minus root 3 over 2 minus root 3. Because this 2 minus root 3 is the conjugate of this. So, we multiply the numerator and the denominator. Okay, so we have, of course, put your brackets to avoid confusion. So, from here, we have 4 times 2 is going to give us 8. And, of course, minus 4 times root 3 is going to give us 4 root 3 over, because this is difference of 2 squares, we say that it is 2 squared minus root of 3 squared. And root of 3 squared is same as 3. So this is 4 minus 3. So we have 4 minus 3. And 4 minus 3 is 1. That means the whole of this is 8 minus 4 root 3. Alright. The second one, we have 7 over root 5. Actually, it is stored here, but no problem. Let us continue. We have 7 over root 5 minus root 2. The conjugate of this, because minus is here, the conjugate is going to be plus. Same way the conjugate of this plus is minus. So we are multiplying this. We are multiplying with root 5 plus 2 over root 5 plus 2. That's the conjugate. So in this case, we are going to have 7 times root 5 is 7 root 5 plus 7 times 2 is going to give us 14 all over. In this case, we are going to have root 5 times root 5, which is 5. So we are going to have 5. Then minus 2 times 2 is going to give us 4. You understand? I hope you understand the algebra behind this 5 minus 4. Do not say that because we are having 5, we are having 2, that is how it works. No. The algebra is this. Let me show you. We are going to have root of 5 minus 2 times root of 5 plus 2. Now, root 5 we multiply root 5, we have 5 as our answer. This we multiply this, we have 2 root 5. Now, this we multiply this, we have minus 2 root 5. Of course, minus times plus is minus, and then 2 times 2 is going to give us 4. Because of this plus 2 root 5 and minus 2 root 5, because we are having them, both of them will cancel each other. We now have 5 minus 4. That is how we got this. Okay, so in continuation, we have, okay, you can rewrite this. You can rewrite this to be 14 plus 7 root 5. So this becomes 14 plus 7 root 5 all over. 5 minus 4 is going to give us 1. Wow, coincidentally. So we have over 1. You can equally leave it like that. So in this case, we have root of 3 minus root of 2 over root of 3 minus root of 2. Okay, so and this is going to give us root 3 minus root 2 up. And in this case, this is root 3 squared minus root 2 squared. which is 3 minus 2. And 3 minus 2 is 1. So the answer to this is simply root 3 minus root 2. Okay, please do not think or say that because we had 1 here, we had 1 here, and we are having 1 here, that all your denominators will give you 1. No, that is not the case. You understand? We actually chose this question from the textbook. You understand? Okay, so in our next video, we are going to do rationalization where the denominator or the final denominator will not be 1. Hope to see you there. Thanks, and God bless you.